We have three data sets here, x1, x2, and x3. And we have a mean and median for each one. X1 bar is 30.4, median 1 is 27. X2 bar 64.5, median 2 is 68. X3 bar is 51.7, median 3 is 52. And if we were to look at these data sets, we have a stem and leaf display here for all three of them. And the first one appears to be bottom heavy. We have a lot of data values towards the bottom. We have several teens, and as we travel up through the data, we see that the range is going to be 74. We have the range is actually the same for all three data sets. So as far as the range goes, there's not a lot that we can tell about these data sets in terms of how they compare. The ranges are all the same. The minimum value is 10, the maximum value is 84. But we do appear to have some differences in these data sets in how the data values are clustered. We have 1, 2, 3, 4, 5, 6 teens in the first set here. And we have 2 20s, 2 30s, 4 40s, and 1 80 value here. We have one extreme value that is going to definitely make a difference. We have an extreme value in the second set also at 10. And we have 3 50s, 1, 2, 3, 4, 5 60s, 3 70s, and 3 80s. And in the third set, it appears to be fairly symmetrical. We have 1 teen, 1 20, 2 30s, 3 40s, 3 50s, 2 60s, 2 70s, and 1 84 value. So we have this 84 data value that's extreme in the first data set, and it's causing the mean to be greater than the median. Remember how we talked about the median is much less sensitive to extreme data values than the mean. And this implies, in this case, that we have a data set that is skewed right. Just because the mean is greater than the median doesn't mean that the data set is skewed right, but if a data set is skewed right, the mean will be greater than the median. In the second set, the mean is less than the median. We have an extremely small data value in this 10 value here. And whenever you have this case where the mean for a data set is less than the median, then we have a case that implies a data set that is skewed left. So if the mean is less than the median, it is implied skewed left. Now again, just because the mean is less than the median, it doesn't draw the conclusion that the data set is skewed left. But if a data set is skewed left, the mean will be less than the median. In the last data set, we talked about how it appears to be pretty evenly spread out from the bottom of the data values up to the top. And we see that the mean and the median are very close in value. And as a matter of fact, if we rounded to whole numbers, they would be the same. So the mean for this data set is approximately equal to, not exactly equal to, but approximately equal to the median. And whenever we have that case, it implies that we have a symmetric data set. So the things to notice here then is that if we have a data set that is skewed right, then the mean will be greater than the median. If the data set is skewed left, the mean will be less than the median. And if the data set is symmetric, the mean will be equal to the median.